Okay, good afternoon. We are going to look how to use power series to solve the ODE. For example, here we have the second order differential equations y double prime plus pxy prime plus qxy equal to 0. For power series solution, we assume yx in terms of power series, am, xm, where the m from 0 up to infinity, or in the expansion form, we have a naught plus a1x plus a2x squared plus a3x cubed, up to infinity terms. Then we will use the expansion form, will be easy. We will plug in the y as a power series of a naught plus a1x plus a2x squared plus a3x cubed. Then you have the y prime. Once the y primes will be, you have to differentiate the y here respect to x. So your ddx a naught will have 0, and then your ddx a1x will get a1 here. ddx a2x squared will get 2a2x. ddx a cubed x cubed got 3a cubed x squared. Here, if we have 4 term, a4x power 4, first we'll get 4a4x cubed and so on. If we have a second derivative, then we differentiate the first derivative one more times. So differentiate a1, we have 0. Differentiate 2a2x, we get 2a2. Differentiate 3a cubed x squared, so you got 2 times 3, which is 6a3 x squared. X 2 times 3, 6a cubed x power 1. Differentiate 4a4 x cubed, you got 3 times 4, which is 12a4 x squared, and so on. So means y prime, it will, this one will be placed in here. And then for your y double prime will be placed by here. After that, we expand collecting the same power of term, combine left side, right side to get the coefficient for a naught, a1, a2, a cubes. Okay. Plug in back the a naught, a1, a2, a cube, then you get the solution for your y. Okay. And take note that if you solve first order ODE, then you will left your constant a naught as a constant a, as we solve it in the either your separable, linear, exact, or homogeneous equation. If second order, then you will have a constant in terms of a naught and a1. With this, let's look at the first example. Solve y prime equal to 2xy by separable techniques and power series. Okay, first of all, we look how to solve it by separable techniques. Separable. Okay, notice that this one, you have y prime is actually the dy dx equal to 2xy. Separable techniques. Okay, so we are going to separate y, function of y to dy, and then bring the dx to function of x. So you have dy over y equal to 2x dx. Now we successfully bring function of y to dy, function of x to dx. Then you just integrate both hand side. So integrate dy over y, you have ln y. Integrate 2x dx, so you have plus 2 divided by 2. C. Okay, just plus c here. Okay, and then if you want to get y as title, you may take take exponent as at both hand side. So you get e again ln y equal to exponent x squared plus c. Then e ln y is actually you have y, and then exponent x squared. We break it, become exponent c. Okay, exponent C is a constant. Let's rewrite it as A exponent x squared. So you get the solution by separable technique is actually y equal to A exponent x squared. So if you solve it using power series method, okay, your constant A will be in terms of A nodes. Okay, let's check whether you can get back power series solution same with what you obtain using separable techniques. Okay, so by separable technique, by power series, we assume y is a naught, a1 x, a2 x squared, a3 x cubed, okay, and so on. So differentiate, okay, because we have only y prime, so we differentiate it. We have a1, 2a2x, 3a3x squared, okay. Let's say if you got here a4 x power 4, so 4a4 x cubed, and so on. So substitute okay, the y prime which is actually we have a1 plus 2a2x plus 3a3 x squared plus 4a4 x cubed equal to 2x, okay, y is here, this one, see, a naught plus a1x plus a2x squared plus a3x cubed, if you want, a4 x power 4. Okay, and then the right hand side we may expand it. Okay, expand it. Let's say we put it here. 2. So you got 2. I think 2 a naught x plus a1 x squared plus a2 x cubed plus a cubed x power 4 plus a power 4 x power 5. Then you can compare, okay, the same terms, okay, the same power of term. In this case, I compare here, let's say the constant terms, constant term, which is x power 0. Okay, x power 0, left side you have a1. Right hand side, this is start from x power 1. So mean a1 is equal to 0. And you can compare x power 1. Left side, right side. Left side, okay, the coefficient for x power 1 is 2a2. Okay, 2a2. Okay, right hand side, don't forget, each term in the right hand side you have to multiply by 2. So this x power 1, so 2a2 equal to 2a naught. Mean a2 equal to a naught. Okay, and then you compare x squared term, okay, for the x squared term, let's see, okay, the x squared term, this one is the x squared term. So the x squared, you have 3a cubed equal to 2a1. So the a cubed equal to 2 over 3 a1. Okay, however, a1 is 0. a1 0. That's why it's the a cubed equal to 0. Then we compare this term, a cubed term, left side, this is x power 3, x cubed term. The coefficient is left side is 4a4. Right hand side, okay, don't forget 2 times a2. So a4 is 2 divided by 4 is half a2. Okay, plug in A2 is 0. A2 is A naught, so you have half A naught. Okay, if you 1, 2, 3, okay, let's say a few more terms. Okay. If you only want 3 terms, I think it should be enough already. If you want the first 3 terms, and you just want, okay, you got cos k, the first order, you will have the in terms of A naught. Then let's say we want the first 3 terms enough, okay. Then the y, you got A naught 1 term, so A2, A4, already 3 terms. So if you want more, then you compare. Okay, x power 4, x power 5, and so on. Okay, y, okay, the solution y as what we assume in the power series is y equal to A naught plus A1x plus A2 x squared plus A3 x cubed plus A4 x power 4, okay, and so on. Okay, as I said, okay, the constant for first order will be in terms of A naught. So that's why you will solve A1 onwards in terms of A naught. Okay, A1 is 0. This is 0. A3, 0. So you got, that's why I said 1, 2, 3. We just want the first 3 terms, then we can stop here. If you want more terms, then it takes it, comparing x power 4, x power 5, and so on. Okay. So A2 is actually, you have A naught x squared. A4 is half. Okay, half A naught x power 4. Okay, factor out the A naughts. So you have 1 plus x squared plus half x power 4. Okay, and you must wonder why the solution is different with the what you obtain in separable techniques. Okay, it's in power series method, and then actually we have the power series for exponent x. Power series for exponent x is actually, if this is exponent x, is 1 plus x squared over 2 factorial plus x cubed over 3 factorial. This is a power series for exponent x. So you notice they are almost the same pattern. You have 1. X here is actually x squared. So x squared, you have 2 factorial is actually half. At 2 factorial is 2, so this is actually half. So x squared become x power 4. It is actually, if this is a power series for exponent x, okay, by substitution techniques, if you have exponent x squared, in power series technique, if x here is replaced by x squared, then you just replace the power series expansion by x squared too. So you should have 1 plus x squared plus x squared, you square it. So 2 factorial. And then x squared cubed 3 factorial. That's why you get this is 1 plus x squared plus, okay, this is half x power 4. Okay, 3 factorial is 6, so 1 over 6 x power 6, and so on. So you compare actually, this is a power series expansion for exponent x squared. So that's why after you change it in terms of the in this one, this expansion is actually exponent x squared. Now you notice you get the same solution as what you obtained in separable techniques. Okay, this is what we call power in the substitution of power series. Okay, for example, if you want, let's say if we want power series expansion for exponent negative x, then just change x here become negative x. So this will be negative x squared over 2 factorial plus negative x cubed over 3 factorial and so on. So means this is a general for exponent x. If we want exponent 2x, so x here is change by 2x. X here 2x, here x here 2x. But make sure you have 2x bracket squared, like this. Negative x bracket squared. So this will get positive, this will have negative. Okay, and then the second example, similar patterns. Similar pattern, solve y prime equal to 3x squared y by separable and power series methods. Okay. Same with the first example actually. Okay, by separable technique. Down first. So the y prime is actually, you have dy dx equal to 3x squared y. So bring y to dy, bring dx to 3x squared. So you have dy over y equal to 3 times x squared dx. Okay. And then integrate both hand side. So integrate 1 over y dy, you get ln y. Okay, this one you get x cubed plus c. Similar pattern with the first example. So when you take exponent both hand side, you have e ln y equal to exponent x cubed plus c. E ln y is y. So exponent x cubed, can break it become here, exponent x cubed multiply exponent c, which is a exponent c, which is a new constant, a exponent x cubed. So this is a solution by separable technique, and we're going to show, okay, by power series method you should get the same, okay, answer. The equation y prime equal to 3x squared y. So by power series method, y we assume as a naught plus a1 x squared plus, okay, so a1x. Then a2 x squared, a3 x cubed. Okay, and then a power 4 x power 4 plus a power 5 x power 5. Okay, plus let's say a6 x power 6 to be 1, a7 x power 7, and so on. So the y prime, you differentiate the y here respect to x, differentiate a0 0, differentiate a1x, you have a1, differentiate a2x squared, you got 2, a2x, differentiate a cubed x cubed, you got 3, a3x squared, differentiate a4 x power 4, you got 4, a4x cubed. Differentiate a5 x power 5, you got 5, a5x power 4. Differentiate a6 x 6, you got 6, a power 6 x power 5. Differentiate a7 x power 7, you got 7, a power 7 x power 6. So plug in y prime to the left hand side, plug in the y to the right hand side. So you notice y prime. The right hand side with the y here you multiply by x squared. So a1 plus 2a2x plus 3a3 x squared plus 4a4 x cubed plus 5a5 x power 4 plus 6a6 x power 5 plus 7a7 x power 6 equal to, okay, this is the left side, this one. Okay, right hand side is a y multiplied by this one. This expansion, okay, you multiply by 3x squared. So equal this one. This one you multiply, you put the color, y here, you multiply by 3x squared. Equal. So straight away I can, okay, or I can factor out 3 outside. So each term I multiply by x squared. Be easy, I will put it here. So this a notes we have. We got 3x squared times y. So this one you times by 3x squared. So I got 3a naught x squared. So here plus 3a naught x squared. So this one times 3x squared. So 3a1 x cubed. This term times by 3x squared. So plus 3a2 x power 4. This one times 3x squared. So 3a cubed x power 5. Okay, this one times x squared, 3x squared. So 3a power 4 x power 6. Okay. Plus this one up to x power 6 here, I just stop at x power 6. Okay, now comparing the same power of term. A1, 2, 3, 4, 5, 6, A1, A2, A3, A4. Okay, comparing the same power of term, okay, start from x power 0. X power 0. Left side is A1. Right, this is the black color is right hand side. Right hand side 0. So x power 1. X power 1. Left side we got 2a2. Right hand side don't have 0. So x squared term. X squared here. 3a3 equal to 3a naught. So means you have a3 equal to a naught. Okay, for x cubed. X cubed here, compare. 4a4 equal to 3a1. So that's why the, okay, a1 is 0. So a4 will be, because a1 here 0. That's why a4 you get 0. Okay, and then x power 4. X power 4 here. 5a5 equal to 3a2. So 5a5 equal to 3a2. Because a2 0 also. a2 is 0. That's why a5 you get 0. So you can only one term. X power 5. Let's see the pattern 0, 0, A naught. So 0, 0, A5 you should have the coefficient. So A5 you have 6A6. 6A6 equal to 3A3. So means A6 equal to half A3. Okay, A3 is A0. A0 one term, so A3, A6. So we got the first three term. This one I just expand for the first three term. So you got up to A6. Then Y, solution of Y as what we assume, Y is actually equal to A0 plus A1x plus A2 x squared plus A3 x power 3 plus A4 x power 4 plus A5 x power 5 plus A6 x power 6. If you continue, you notice the pattern. You got 0, 0, and then A3 got value, so 2 times 0. A6 got value. If you go to do A7, A7, X will be 0, and then you can be able to find your A9. So here do up to A6. Okay, and then we know A1, A2, 0. A4, A5, 0. A1, 0. A2, 0. A4, 0. A5, 0. Okay, and A3 equal to A0. So A3 is equal to A0. So x cubed. A6 is half A0. So I got the first three term. And then I factor out my A0. I got 1 plus x cubed plus half x power 6. And just now we know that the power series expansion for exponent x is 1 plus x plus half x squared plus 1 over 6 x cubed. So this is actually in the patterns of if x here I replace by x cubed. So x cubed is squared, you got x power 6. So this will be the x power series expansion for x power 3. If x you replace by x power 3 and x cubed, then the power series expansion also, you just replace the x by x cubed. So you got x cubed, you square it, plus 1 over 6 x cubed, and then you power. So you get this is 1 plus x cubed plus 1 half x power 6, 3 times 2 plus 1 over 6, 3 times 3, 1. Hence, this one is actually exponent x cubed, which is tally back with what you obtained using separable techniques. A0, where the A in power series A0 exponent x cubed. Now we look at the last example where we have our equations now is di dt plus I equal to sin 2t, and this is a particular solution. Given t0, I is equal to 1. And I here actually for the current. Okay, and I give you the power series expansion for sin. because here sin 2t you have to replace by its power series. And they give you to show that the answer is I is actually equal to 1 minus t plus 3 over 2t squared, okay, minus half t cubed minus 5 over 24 t power 4. Okay, we just do for the first 3 terms. The other 2 terms you may do it, okay, by yourself. Okay, so step you have, okay, I is actually a naught plus a1 t plus a2 t squared plus a3 t cubed plus a4 t power 4 plus a5 t power 5. So here up to t power 4, I take out one more term. So you got d I dt is a I prime. You have a1 plus 2a2 t plus 3 a3 t squared plus 4 a4 t cubed plus 5 a5 t power 4. Okay. Then units means the I you replace by here. The I dt is this. The units are sin 2t. Okay, this is a power series for sin 2t. Okay, and we have the equation is actually I prime plus I equal to sin 2t. So this is sin t. You expand the power series expansion for sin t first. So m you replace by 0. So negative 1 power 0, you have anything power 0 is 1. So you got t power. When you replace m by 0, you have t power 1. So m is 0. So 1 factorial, which is 1. So you have actually t. Okay. So later on you replace k m by 1. Okay, we cannot see that. I will do it slowly. So make m0, you have like this. Negative 1 power 0 t power 1 divided by 1 factorial. So when m is 1, so negative 1 power 1. So 2 times 1, 2 plus 1, 3. So this is 3 factorial. Okay. And then m is 2. Negative 1 squared. So this t power 5 plus 2. 2 times 2 plus 1 t power 5. So here 2 times 2, 4 plus 1, 5 factorial. Okay. And so on. So negative 1 power 0 is 1. 1 factorial is 1. So you have t. So negative 1 power 1 you got negative. So t cubed divided by 3 factorial. 3 factorial is 3 times 2 times 1. So negative 1 squared is positive. So you got t power 5. 5 factorial is 5 times 4 times 3 times 2 times 1. So you should get this is t minus t cubed over 6. This is positive t power 5. 6 times 4 times 5. 120. You got 5 times 4 times 3 times 2. 5 factorial 5 times 4 times 3 times 2. 120. So this one is sin x. When you expand here, so it's sin t minus t cubed over 3 factorial plus t power 5 over 5 factorial. Okay, now you have sin 2t. The right hand side is sin 2t. Then t here we replace by 2t. So minus, this is 2t cubed divided by 6 plus 2t power 5 divided by 120. So you get this is actually 2t. So you have 8t cubed divided by 6 plus 2 power 5 is actually you have 32 t power 5 divided by 120. So this is simplified. This is 4 over 3 t cubed. Okay. And then you simplify this one by cancel by 8. This is 15. Okay, now you replace k, I prime by this, I by here, sin 2t by its power series expansion, which is 2t minus 4 third t cubed into your di dt plus I equal to sin 2t. Okay, di dt, we have here a1 plus 2 a2t plus 3 a cubed t squared plus 4 a4 t cubed. Plus 5 a5 t power 5. T power 4. Okay, plus with the I have put it here. I will start from, we got a naught plus a1t plus a2 t squared plus a3 t cubed plus a4 t power 4. Okay, the first line is for the IDT. Then equal to Okay, sin 2t must be obtained here equal to 2t minus 4 third t cubed plus 4 over 15t power 5. So check out if this is I, A0, A1t, A2t squared, A3t cubed, A4t power 4. Differentiate it. We have A1 to A2t, 3A3t squared, 4 A4t cubed. Okay, in here I got A5 t power 5, so 5 A5 t power 4. Okay, now comparing, okay, A power 5 t power 5, differentiate, I got 5A5 t power 4. Now comparing the same power of term. Comparing the same power of term, start from t power 0. Okay, t power 0. Okay, you have A1 plus A0, right hand side, okay, right hand side 0. A1 plus A0, right hand side we don't have the constant term, so it's equal to 0. Solve A1 in terms of A0, so A1 is negative A0. Okay, and then you compare t power 1. T power 1, 2A2 plus A1. 2A2 plus A1. Okay, right hand side is equal to 2. So solve A2 in terms of A1, and A1 replace in terms of A0. So you got 2A2 equal to 2 minus A1. 2 minus A1. So your A2 will be 2 minus A1 divided by 2. Okay, whereas the A1 is actually negative A0. So minus with negative A0, so you got 2 plus A0 divided by 2. So you have actually A2 is 1 plus half A0. And then you may compare scale of, actually I got A1, A2 already here. Okay, compare t squared term. T squared term, 3A cubed plus A2, 3A cubed plus A2. Okay, right hand side we don't have t squared, so equal to 0. So mean A cubed is actually negative 1/3 A2. Okay, and then A2 here. Replace the A2. We have negative 1/3. A2 is actually 1 plus half A0. Then we got your A3 is negative 1/3 minus A0 divided by 6. So we got, let's see, the question 1 up to how many terms? A0, A1, A2, A3. I need one more, A4. So t power 3. We need up to A4 term. T cubed 4A4 plus A3. 4A4 plus A3 equal to negative 4 over 3. Right hand side is negative 4 over 3. So solving for A4. So 4A4 will be negative 4 over 3 minus A3. Where's your A4? Okay, divided by 4. So negative 1/3. This divide by 4. Cancel the 4 here. Negative A3 divided by 4. Negative 1/3. Okay, A3 here. That 1/4. A3 we have negative 1/3. Negative A0 divided by 6. Then negative 1/3. This one expand in, we got 1/12 plus A0 over 24. Okay, and then you need to simplify these two. This one. So I times 4 times 4. So negative 4 plus 1. So negative 3 over 12 plus A0 over 24, or is negative 1/4 plus A0 over 24. Now, okay, we can plug in, okay, all the coefficient for A0 up to A4. Okay, where the solution for your power series, you have y equal to A0 plus A1x plus A2x squared plus A3x cubed plus A4x power 4. For first order, the constant will in terms of A0. Okay. Call back, okay, what is A1? Okay, A1 is negative A0. So A1 is negative A0x. Okay. Call back, what is A2? A2 here. 1 plus half A0. A2, actually you have 1 plus half A0 x squared. Okay, find back your A3. Okay, this is A3. Yeah? A3 is negative 1/3 minus A0 over 6x cubed. A4 is here. Negative 1/4, okay, plus A0 over 24 x power 4. And what they want is actually particular solution. Okay, when T0 I equal to 1. Even when T0, oh sorry, so we solve for I, so this I equal to 1. So plug in when T0 I equal to 1. Okay, if this is okay, all here, sorry, because the problem is dependent on T. So X here you change back to T. Yeah? So this is a T, this is T, this one is T, this one is T. So when T0 I equal to 1. So when T0, that means your A0 is 1. Because T0, this one gone, this one 0. So everything gone. So I will just get A0 equal to 1. Then the I is equal to A0. A0 is 1. So A0 minus T. Okay, plug in A0 is 1. Later on, we found A0 equal to 1. Then plug in A0 is 1. So 1 plus half. 1 plus half will be 3 over 2 T squared. So plug in A0 is 1. So you got negative 1/3 minus 1 over 6t cubed. So A naught is 1, so negative 1 over 4 plus 1 over 24t power 4. So which is A naught minus, so A naught is 1. So this is 1. A naught is 1. 1 minus t plus 3 over 2 t squared. This one is times 2 times 2. So negative half, negative 2 minus 1, negative 3. So we got negative 3 over 6t cubed. This is times 6 times 6. Negative 6 plus 1, negative 5 over 24t power 4. 1 minus t plus 3 over 2 t squared minus half t cubed, okay, minus 5 over 24 t power 4. Check. So it is actually equal 1 minus t plus 3 over 2 t squared minus half t cubed minus 5 over 24 t power 4. So it's proven correct. So means conclusions to solve by power series method is very easy. What you need to do, you want to solve for I, then we assume I is actually in terms of power series. You have first order. I prime, we differentiate the I power series expansion of I respect to t, and you have a right hand side is sin t or exponent t or cos t. Then you expand it using the power series expansion. Then you collecting the same power of term, compare left side, right side to get the coefficient for your starting from. For first order, you get solve the A1 starting from A1, A2, A3, A4 in terms of A naught. If you got second order, you will solve A2 because your constant will be in terms of A naught and A1. You solve starting from A2 onwards in terms of A naught and A1. With this, thank you for your attention.